Hello again, and welcome to another Math IB speedrun with me, Vince. So today, we're going to be continuing where we left off in the last speedrun, and we're going to be covering geometric sequences and series. There's a lot of problems to go through today, and so I probably won't be able to do all the problems in the book, but I'll do enough so that we have a general understanding, and it's also a good idea for you to try some problems on your own, so I'll leave some for you to do. Right, let's get on with the problems. So, first we need to know what is a geometric sequence. So a geometric sequence looks like this. So you have the first term as the first term, like an arithmetic sequence. And to get the next term from the previous term, you multiply the previous term by a constant factor. In this case, we'll call it r. And so to get the third term, it's equal to the second term times r, which is equal to the first term times r squared. And so the general formula for a geometric sequence is the first term, sorry, let me just erase that. Is that you multiply the first term by r, which is your common, we call this a common ratio, which is the number you have to multiply to one term to get the next term in the sequence, and then we have raised that to the power of n minus 1. So that is the general formula for a geometric sequence. Okay, now we need to know how to find the sum of a geometric sequence or series. And, well, you can try to investigate this yourself, but I'm going to give it to you straight up that the sum of a geometric sequence is equal to the first term times 1 minus the common ratio to the power of n, where n is, of course, the number of terms you want to sum, divided all by 1 minus r. And this works as long as r is not equal to 1. If r is not equal to 1, if r is equal to 1, sorry, the sum will just be equal to u1 times n, really. Because if the common ratio is 1, it means that every single number in the series or sequence is the exact same number. And so to get the sum, you just multiply that number, or the first number, or any of the numbers, by the number of terms you're counting. Okay, but the thing is, this only works for a finite geometric series, right? Because, if we set n to like infinity, there's no way we can calculate this. But there is actually a way to calculate the sum of an infinite geometric series as long as r is between 1 and negative 1. And that method is, instead of using this formula above, we can use this new formula, u1 is divided by 1 minus r. And so the reasoning behind this is that for numbers between negative 1 and 1, when the common ratio is between those, as n gets very large, r to the power of n tends to 0. Like if you have say r is 1/2, 1/2 to the power of infinity, or n, will tend to 0. And this is more of like a limits problem, and we'll get to that much, much later in the course. But for now, just know that if you want to calculate the sum of an infinite series of an infinite geometric series, we use this formula. And as long as negative 1 is less than r, which is less than 1. Okay, now we can jump right into some problems, and yeah, let's go. So I'm going to be selecting which problems I'm going to do. If you have a request for a problem, leave it in the comments or tell me, and I'll maybe make a video on it if it's a problem I haven't covered. So the first problem we're going to do is 1a. Or 1 is write down the fifth term and the general term of each of the following sequences. and we're going to do it for 1, 3, 9, and so on. Okay, so, well, what's the difference between, how do we get to 3 from 1? Well, we have to multiply it by 3. How do we get to 9 from 3? We have to multiply it by 3. So the common ratio of this geometric sequence is equal to 3. To get the fifth term, we multiply 9 times 3 to get the fourth term, sorry. And to get the fifth term, we multiply 9 by 3 by 3, which you should know is equal to 81. So 81 is our fifth term. And we need to get the general term of the sequence, and if you remember, the general term of a geometric sequence is equal to the first term, in this case 1, times the common ratio, which is 3, to the power of n minus 1. In this case, the 1 is kind of irrelevant, it won't do anything. So the answer is simply 3 times n to the minus 1. Yeah. Just note that that the first term will be 3 to the 1 minus 1, otherwise 3 to the 0, which is simply 1. Okay. Now let's move on to the next question. We'll just do another simple geometric sequence. So the sequence in this case is -3, 3, -3, 3. And this is a bit of a tricky one. It's a bit of a trick question. So to get from -3 to 3, we multiply it by -1. To get from 3 to the -3, we multiply 3 by -1. And so the common ratio in this case is simply -1. To find the fifth term, well, it's just 3 times -1, 3. So that is the fifth term of this sequence. And to get the general term, well, we know that r is equal to -1, and the first term was -3. So we know that the general term is equal to -3 times -1 to the power of n minus 1. Easy peasy. So, okay, let's move on to our next question. So our next question is, determine the common ratio and write the terms indicated in each of the following sequences, which is question 2. So part A, which is 63, 21, 7, and we need to find the sixth term. So this sequence is also quite simple. Well, to get from 63 to 21, we multiply by 1/3. From 21 to 7, we also multiply by 1/3. So the common ratio of this sequence is 1/3. So we've already found the common ratio. Now we simply need to find the sixth term. And remember, to get let's just get the general sequence. So un is equal to, first term is 63 times 1/3 to the power of n minus 1. So to get the sixth term, we substitute 6 into here. So u6 is equal to 63 times 1/3 to this 5, which is equal to 7 times 1/3 to the 3, which is equal to 7 divided by 27. And it's usually okay to leave your answer in this kind of form, like as a fraction. Okay, let's move on to another question. Okay, I'm going to skip this one. Let's get to some more interesting questions. Determine the number of terms in the following sequence. And this is 3a, and it's 0.02, 0.06, 0.18, all the way to 393.66. Okay. So the pattern is pretty simple. To get to the next term, we multiply by 3 each time. So the common ratio is 3, and our first term is equal to 0.02. So our general formula is equal to 0.02 times 3 to the n minus 1. So we want to find the number of terms in the sequence, and so we can simply substitute 393.66, which is the last term in the sequence, and we'll get what term that is. So it's 0.02 times 3 to the n minus 1, and by solving for n, this gives us the final term and the number of terms. So 393 divided 0.66, we need to divide that by 0.02, and that will be 393.66 divided by 0.02. That's equal to 19,683 is equal to 3 to the power of n minus 1. And so, I mean, at this point, we would like to use a logarithm. So this would be log 3 to the 19,683 is equal to n minus 1. And if you're not too familiar with logarithms, what this means is that the n minus 1 square root of this large number is equal to 3. Or in other words, 3 to the power of n minus 1 is equal to this big number. But it's something that we and calculators can handle, and so it allows us to punch the sum into our calculator to solve it. Now, if your calculator doesn't have like this function where you can put in like you can actually specify the small base, it just says log. What you can do is you can simply type log 19,683 divided by log 3. What this assumes is, of course, the calculator assumes you're working in base 10, and I think we'll get onto log tricks a little bit later, but just know that this is a handy trick you can do for logs if your calculator is bad like mine. So we have log 19,683 divided by log of 3. That's times, and I got 9. So n minus 1 is equal to 9, and therefore n is equal to 10. So there are 10 terms in this sequence. Pretty easy. So let's go on to another question. I think how I'm going to do this is I'm going to jump every 2 questions because if you already know the content, it's kind of, I would say it's redundant if you know a topic to keep on practicing it. But I would definitely keep on practicing these questions and go through every single one until you get how to solve them. So let's jump question 4, go to question 5. The third term of a geometric sequence is 6, and the fifth term is 54. Find the 2 possible values of the common ratio and the 6th term of each sequence. So we know that the third term is 6, so 6 is equal to the first term times the common ratio to the power of 2, and 54 is equal to the first term times the common ratio to the power of 4. Notice this is fifth term, but it's 4 because this should be n minus 1, and 5 minus 1 equals 4. So to get the common ratio, we can simply divide these two, and we get r squared is equal to, more or less we substitute 6 here. So let me just show you the full working out. So 54 is equal to the first term times r squared, which is 6 is equal to the first term times r squared, so it's equal to 6r squared. So r squared is equal to 9. 54 divided by 6 is 9. So the thing is, the 2 possible values of the common ratio is plus or minus 3, because remember, if you square a negative number, it becomes positive, and so that's it. Now they want us to get the 6 terms of each one. So first we can find the first term. That would probably be the best. Actually, no, we can just straight up multiply it to 54. So the 6th term for the first case is 54 times 3, which is equal to 54 times 3 is equal to 162. And the other case, 54 times negative 3, is obviously equal to negative 162. And so these two will be the two answers for the two sequences. Okay. Was it jump 6? Now we're going to 7. So seventh question, the numbers 3a plus 1, a plus 2, and a minus 4 are three consecutive terms of a geometric sequence. Find the two possible values of the common ratio. Okay. So as usual, we can assume more or less that this is the first term, this is the second term, and this is the third term. So what we have is the first term is equal to 3a plus 1. The second term is equal to the first term, so 3a plus 1 times the common ratio. And so actually, let's erase this. And we can just say a plus 2 is equal to 3a plus 1 times r. And similarly, a minus 4 is equal to a plus 2 times r. So we should be able to solve this pretty quickly. Let's see, where would we start? I would just substitute a plus 2 into here, honestly. So we have a minus 4 is equal to, is this the best way to do it? Hold up, let's not be cheeky. Find two possible values of the common ratio. So we know that equals that equals that. So I guess we can just, here we can just try subtracting. What am I doing? What am I doing? Oh, okay. So we can say r is equal to a minus 4 over a plus 2, of course. And then we can substitute that into here. Or actually up into here, technically. Yeah? R equals a minus 4 divided by a plus 2. Am I being silly? I think I'm being extremely silly. A plus 2 divided by 3a plus 1. So that. So a plus 2. Oh, I guess we could just go like a plus 2 squared is equal to 3a plus 1 times a minus 4. Yeah, this would probably work, honestly. So this is a pretty hacky method. A squared plus 4a plus 4 is equal to 3a squared plus a minus 12a minus 4. So this would be what? 2a squared minus 11a minus another 4a minus 15a minus 8 is equal to 0. So our A values are either equal to 2A, A, and this would be, of course, -8 and 1. So we have A is equal to -1/2, or A is equal to 8, I guess. Yeah, okay, this works. Let me just go through what I've done. So more or less, we know that A plus 2 over 3A plus 1, which should be the common ratio, because this is the second term divided by the first term, is equal to the third term divided by the second term. In a geometric series, that's always true, and so we cross multiply. So we multiply both sides by 3A plus 1, multiply both sides by A plus 2. So we get A plus 2 squared equals 3A plus 1 times A minus 4, and therefore A squared plus 4A plus 4 is equal to 3A squared plus A minus 12A minus 4. So it simplifies into a quadratic, which we can solve to get A. And so we now need to find the two values for the common ratio. I believe the common ratio is equal to A minus 4 over A plus 2. This is the common ratio. So we can substitute first -1/2 and then A. So for -1/2, we have -1/2 minus 4 divided by -1/2 plus 2, which is equal to -9 over 2 divided by -3 over 2. So that's equal to -3. So the common ratio in this case would be -3. And for the case where A equals 8, we have 8 minus 4 over 8 plus 2, which is equal to 4 over 10, or 2/5. So our two possible common ratios are -3 and 2/5. So that's how you solve the problem. Bit tricky, that one, but it's okay. Got there in that. Scroll in. Help. Okay. So jump 8. We want to go 9. So 9. Find the following series for the number of terms stated. And I'm going to go straight to D. Let's jump right into 0.1 minus 0.03 plus 0.009 minus 0.0027, and so on for 15 terms. Okay, so we know that the common ratio is clearly negative times -0.3. Yeah, and our first term is obviously 0.1. So we need to use our friendly formula to find the sums, which is that the sum of the first 15 terms will be equal to the first term, 0.1, times 1 minus r to the n, so 1 minus -0.3 to the 15, all divided by 1 minus r, so 1 minus 0.3. And this should be okay. Let's just multiply everything out. Grab the calculator. 0.1 times 1 minus, so we need to know -0.3 to the power of 15, which is not fun. We can just say 1 minus that. So 1 minus -0.3 to the power of 15, which is actually more than 1. Multiply this entire sum to, it's actually like 1.000000143, something like that. Multiply that lot to 0.1, and then we get 0.10000 something until 14, and then we want to divide this by 1 plus 0.3. So 0.0014 divided by 1.3 is equal to 0.0769 from my calculator. Yeah, that seems plausible. Since 0.1 minus 0.03 is around 0.07, and the answer we've got is just a tad bit bigger than that, so it seems like a reasonable answer. Okay, Let's go on to the next problem. In this case, 11. Show that a geometric sequence with first term 3 and seventh term 1 divided by 2, 4, 3 has two possible sums to infinity and find them. Okay, so we know the first term is 3, and we know the seventh term is equal to 1 divided by 243. So the common ratio is clearly 1/3 or negative 1/3. The reason why it could be either is since we are going positive, negative, positive, negative, positive, negative, by the seventh term, regardless of whether the common ratio is positive or negative, it will be equal to that term to the power of 6, and even if it's a negative number to the power of 6 will be positive. So, to find the two possible sums, one sum will be 3 divided by 1 minus 1/3, and the other sum will be 3 divided by 1 minus 1/3. So for this one over here, this is 3 divided by 2/3, which is equal to 9/4. So that's one possible answer we could have. And over here we have 3 divided by 4/3. Oh, why is it in green? 3 divided by 4/3, which is equal to, oh, sorry, 9/2 on this side. 9/2, and on this side, 9/4. Nice. So, yeah. Well, minus 1/3, 4/3, yep, should be 9/4. So those are our two answers. Let me just check that's correct. So, go to the answer key. See, where is it? Hold on. Exercise 1C, where are you? Yeah, sorry, they're correct. I just checked right now. So, let's move on to the next question. Final two questions for the speedrun. So we have the second term of a geometric series is 28, and the third term is 28 times 1 minus a. Find the common ratio given that the series converges and the sum of the first three terms is 147. The common ratio is 1 minus a. I don't know why they gave us a. Yeah, I have no idea why they gave us a. So the common ratio is clearly 1 minus a, since to get from the second term to the third term, we multiply by 1 minus a. The sum of the first three terms is 147. So we know that sum of the first three terms, let's think. Okay. And so we actually know the first term, as long as we use the variables they gave us. So the first term would be actually 28, the second term divided by 1 minus a, which is the common ratio. So, I mean, I guess we can do like something like 28 over 1 minus a plus 28 plus 28 times 1 minus a is equal to 147. This seems a bit cheaty, but I guess this would work. So we have really here 28 divided by 1 minus a plus 56 minus 28a is equal to 147. So 28 plus 56 times 1 minus a minus 28a times 1 minus a. Oh, I should have just subtracted. What's 147 minus 56? 91. So this should be just minus 91 is equal to 0. Okay. And so we know that 28 minus 91 plus 91a minus 28a plus 28a squared is equal to 0. So 28a squared, what's 91 minus 28? 63. So plus 63a minus 63, I believe, is equal to 0. Yikes. So I'm going to use quadratic formula here. So negative b, negative 63, plus or minus the square root of 63 squared, minus 4 times 28 times negative 63. So this definitely has two answers. Divided by 2 times 28. So that's equal to negative 63 plus or minus the square root of what's 63 squared? 63 squared is 3,969 minus 4 times 28 times 63, times negative 63. So it's actually plus 7,056. Divided all by 56. So we have negative 63 plus or minus the square root of 7,056 plus 3,969, which is 11,025. I don't know off the top of my head whether this, it actually does, it is a square number. So we have negative 63 plus or minus 105 divided by 56. So A has two possible values, but the last thing we're given, if we scroll all the way back up, is that the series converges. So that means A must be between negative 1 and 1. And for this value, the only value of A that will be between negative 1 and 1 is when we actually add 105 and divide by 56. Since the result will be less than, the result will be less than 1. So we have 42 divided by 56, otherwise known as 6 over 8, or 3/4. Okay, it was a very long, remember this is A. So we remember that the common ratio is actually equal to 1 minus A. We go all the way back up, not that. The common ratio is actually equal to 1 minus A. So we have to get 1 minus 3/4, which is equal to 1/4. So that should be the common ratio. Yeah. Pretty long problem, but we've got the answer correct, and yeah, just checked it with the answer. So, on to the final problem of this speedrun. So, final problem is write the first 4 terms of the series and determine for what values of x this series converges. Find the value of the series when x is equal to negative 0.8, and let me just write out the series because it's in sigma notation. So the series is starting from 0 to infinity, x over 2 plus 1 to the I. Negative 1 to the I, x plus x over 2 plus 1 to the I. Definitely very tough. So, I guess let's look for the first 4 terms of the series first. The first term is pretty straightforward. Since I equals 0, the first term will simply be 1. So, we know our first term is 1. Our second term will be negative 1 times x plus 2, x over 2 plus 1. I guess we should expand it. So this would be, what, negative x over 2 minus 1. So far, so good. So our third term, yeah. Our third term would be, well, negative 1 squared times x over 2 plus 1 squared, which is equal to x squared over 4, x plus 2 squared, plus x plus 2 times 1 times 2, plus 1. And our fourth term would look like negative 1 cubed times x over 2 plus 1 cubed. And what would this be equal to? This would be equal to negative x cubed over 8. 1331, so... Sorry, 1221. Am I confusing myself? No, 1331. What am I doing? Plus 3x over 2. Oh, no, sorry. It would be plus x over 2 squared. X squared over 4. 3x squared over 4. Oh, sorry, this would be minus, of course, because we have the minus 1 stuck there. And then we would have minus 3x over 4 over 2. And sorry, I don't know why I wrote 4. This should be 2. Minus 1, finally. So those are the first 4 terms. And, well, now to solve this problem, we need to know the common ratio. And the common ratio is pretty straightforward. If you haven't worked out what it was with my working out below, the common ratio is equal to negative x squared minus 1. And so we need to determine for what values the series converges, and it's when, remember, negative 1 is less than or equal to r, which is less than or equal to 1. So this entire thing over here has to be between those bounds. So negative 1 is less than or equal to negative x over 2 minus 1, which is less than or equal to 1. We can add 1 to everything, so we can have 0 is less than or equal to negative x over 2. It's less than or equal to 2. Multiply both by 2. So 0 is less than or equal to negative x, less than or equal to 4. And then we just flip the negative sign. So we have 0 is greater or equal to x, which is greater or equal to negative 4. So as long as x is between negative 4 and 0, this series will converge. And finally, we need to find a value of the series when x is equal to negative 0.8. And, okay, well, when x is equal to negative 0.8, we know the first term is 1, clearly. And we know that the common ratio is equal to negative x squared minus 1, which is equal to negative 0.8 over 2, minus 1. Why did I say squared? And this would be 8 over 20, 4 over 10, 2 over 5, negative 2 over 5 minus 1. Does this converge, or am I being silly? Oh, negative 0.8. Okay. So negative 0.8. So otherwise positive 2 over 5 minus 1, which is equal to negative 3 over 5. So The first term is 1, so it will be 1 over 1 minus 3 over 5, which is equal to 1 over 1 minus 3 over 5 is equal to 8 over 5, so series will converge to 5 over 8. And that is the final answer. Let's just check if I am right. Yep, so we're right, and this is the final answer. I hope you enjoyed this speedrun of geometric sequences, and if you are looking to continue, I hope to see you in the next video. See you then!